Here are quick solutions for the first formative quiz. In the first function, we're given an algebraic description of our function, and so the two kinds of questions that we have, one is evaluate, one is solve. The difference between those is that in the first problem, we're told an input that goes into the function. So remember when we read this, the -5 goes in place of the t, whatever the letter is here, the -5 is going to replace that. And so f of -5 is going to be the result of putting -5 into this expression where t is, and then evaluating the numerical value of that. So we'll have f of -5 is 1/2 -5 plus 3, which is -5 halves, plus 3, which is positive 1/2. The other kind of question we could ask is one like this, where we have a mystery input. We don't know what this is, but we do know the output. Notice how that's different here when in this problem, we're given the input -5 and we determine the output that goes with that would be 1/2. Here we're told the output should be -3 and we want to know what input will give us that. So in this case, we can just write down what f of x is equal to because we have an algebra formula for it at the top. If f of t is this, then f of x means make 1/2 x plus 3. In other words, replace the t with an x. So the left-hand side of that equation is literally 1/2 x plus 3. We want that to be equal to -3. So we just do our regular algebra magic. I would subtract, what in the world? I would subtract -3. Sorry, I would subtract 3 from both sides. My reason for doing that is that that gets rid of that. And I'm left with 1/2 x over here and -6 over here. And then multiplying both sides by 2 will tell me that x is -12. So that would be my answer. And if I want to check, I would say this is because f of -12 really is 1/2. So this is me just checking. F of -12, just like in 1a, f of -12 is 1/2 -12 plus 3, which is -6 plus 3, which is 3, which is what it's supposed to be. Okay. So when the input is -12, the output is 3. So I've solved this problem, determining what -3, sorry. -3. Okay. For number 2, it's the same two questions, but in this case, we don't have an algebra formula for our graph. We only have, for our function, we only have a graph. So the key relationship there, remember, is that on a graph, if you know that a point is on the graph, then that point on the graph is an input-output pair. That meaning that f of whatever the first number is equal to the second number. So when we any point, any dot that we make on this graph is going to correspond to a function value, an input-output pairing for the function. So when the question asks for the value of g of 4, so that means when I say g of 4 equals what, that means I'm looking on the graph for a point whose first coordinate is 4 and the second coordinate is the mystery number. So I can look across my graph and find a point on the graph whose first coordinate is 4, right here. So point right there has its first coordinate 4 and it's sitting on this graph. So I'll write down the coordinates. 4, 2 are the coordinates. And so now I can go back and answer my question. 2 is the second coordinate. So 2 is the mystery number here. Well, I want to write that. So the mystery number is 2. So the mystery number here is 2. So that means g of 4 equals 2. So my answer would be 2. Same thing happens for this one. If I have g of a mystery number equals 4, that means I'm looking for on the graph a point that has first coordinate unknown and the second coordinate 4. So I can go searching for that. Looking for a point whose second coordinate is 4. It would be right here. So point right here, mark it with an X, is a point on the graph whose second coordinate's 4. So this point has coordinates roughly 4.3, 4 would be roughly the coordinates of this point. So that tells me that g of 4.3 is approximately 4. And so my answer here, remember my answer is to figure out what the x has to be, what is the input. So the answer would be x would be about 4.3. So the question is asking us for the input that gives us that output, so the answer would be about 4.3. Problem number 3, we're using the rate of change formula from section 1.3. By the way, the questions 1 and 2 are from the 1.1 section of our book, and so there were questions like those in the 1.1 homework. So if you want to practice some more with some randomized versions, then open up the section 1.1 homework again and look for those types of questions, especially questions like number 2. There were a couple of those on the 1.1 homework. Okay, so average rate of change formula is just the change in outputs divided by the change in inputs. So whenever we have a function that we're given over an interval, we're going to have to be told the inputs that we're talking about. So the inputs are 1 and 5, the two n's here. So our inputs are going to be 1 and 5, but we're always going to have to figure out our outputs. So let me do that first, because I know I'm going to need them. So figuring out the outputs for these inputs is exactly the same problem as you had in number 1a. So the way we do that is we plug the input into the formula for the variable. So the formula at the top of the page is 1/2 t plus 3. And so I've made the t1 for this first one, and I made the t5 for the second one. So this is 3.5, this is 5.5. So those are my outputs. My average rate of change formula says that I'm going to take the change in the outputs. So let me write down the formula so we have it as a reference. But the idea of it is that we're doing the change in the outputs divided by the change in the inputs. So that's going to be 5.5 minus 3.5 in the numerator, and 5 minus 1 is 4 in the denominator. So if you do that, on the numerator you have 2, denominator you have 4, so that's 2/4 or 1/2, 0.5 be our average rate of change. The significant thing about that is notice that that is exactly the same thing as the slope of that line. In that case, the f function, if you go look at it, is linear. So the graph of the f function is a straight line. And this is just reminding us that that idea of average rate of change really is just the slope in the case that the function is a straight line. So average rate of change can be applied to anything, even curvy things. But when we do ask for the average rate of change of something that's a straight line, the average rate of change corresponds exactly to the slope, which isn't surprising. The formula looks almost the same. So we're going to approach the second problem in the same way. I'm told the inputs that I need to use. I need to use inputs x equals -1 and x equals 3. Those are the two inputs that I need to use. I'll first figure out what the outputs are. Forget the name of my function. G of -1 and G of 3. In this case, these are going to come from the graph, which I still have barely on my page up there, so I can read this off. When the input is -1, the output should be 3, about 3, because of this point right here. And when the input is 3 for this other point, the output is -1. So this question has a lot of symmetry to it. That was not intentional. Those values could be anything. But the idea is that we have to get those values from the graph. And then my average rate of change formula says that I take my, still not called f for this problem, I take my outputs, so g of 3 minus g of -1, and divide by the change in the inputs. Two inputs are 3 and -1. And so now I just got to grab that information from what I wrote down. The output g of 3 we said was -1. The output g of -1 we said was 3. So I'm just finding this value. G of 3 is -1. G of -1 is 3. The denominator is 3 minus -1, which is +4. So I have -4 over +4, which is -1. Okay, so that is the solutions to formative quiz number 1. There's also a hard copy of this PDF that's posted in D2L.